This video will demonstrate how to use a Raspberry Pi as a remote rig interface for both audio to and from the rig, and also to control the knobs on the rig using FLRig. The K3S ELECRAFT has a USB port on the back of it that we're using for both audio and to control the rig. We're using the Raspberry Pi in a wired Ethernet ad hoc connection between the Raspberry Pi that you see sitting on top of the MFJ artificial ground and this Ethernet cable connecting to this laptop. This provides a very stable audio connection, and it's a lot lower latency than it would be as far as going through being able to lower the buffers so you don't get audio dropouts. I'll go over that in a second. Anyway, here we have the Raspberry Pi, and you see these toroids that's going from a USB cable from there to the back of this ELECRAFT K3S. Right now we're transmitting at zero output. Zero outputs. The watt meter is showing zero outputs, so is the scope. Just for this demonstration until we turn everything up here in a second. So let's go to the laptop now, and I'll show you the basic setup. Here we have for the Morse code, we have a mic jack coming in with the side tone from a 555 being keyed by a CW keyer. And we have a microphone input that's going through a few DSP processing, and it's going to the headphones and to the screen recorder so you can hear it, but it's also going through audio over IP to zita-njbridge. I found this to be the best on a local area network as far as providing high quality 24-bit audio at very low latency. Right now I have it at the standard settings, which provides about 10 milliseconds of buffering, but you can lower that down. I've been able to lower it down to 3, and that lowers it down even more as far as the time that it takes to send a tone and to hear it back from the K3S's own audio input side tone monitor. So this USB sound card on the Pi here, this is the Pi's desktop screen. Here's FLRig, which controls the frequency, power, volume, RF, IF control, the input, gain, mode, and the bandwidth. Now the extra tail that you hear after I finish talking is the monitoring audio from here, from the rig itself, before it turns off. I'm blocking the rig's audio, the side tone, the input monitor, the input sound card monitor, by using an application called, this ducking application called Ducka. Right here. And that allows me to hear the latency in much lower than it would be otherwise. It's still not that bad. I'll send a tone. So I'm hearing the tone immediately on this laptop. But if I lower this ducking down, you'll hear the two tones. The second one is the repeat back from the rig itself, from the K3S's monitoring audio, input monitoring audio. So that is pretty fast, but it still might cause some issues as far as speaking and how you're able to key your paddles. So here's the setup at the laptop. Right here we have the mic cable. We've split it into left and right channels so I can have both audio from the CW side tone, which is right here. So I have the paddles and straight key going into this 555, keying the 555 to turn on with a side tone, which sounds really bad. we're not going to use that side tone. We use that side tone to key a software CW keyer called the Zamgate CW keyer, and I'll show you that in a second. So we have both microphone and Morse code going into one mic jack because we can split left and right functions. So inside the system here is the mic jack. CW side tone goes to the Zamgate CW re-keyer. This trigger is activated by the side tone itself. And I'll spare you the harshness of demonstrating that. I'm sure you know what that sounds like. But that side tone at a certain volume and a certain threshold triggers this to turn on the top channel, which allows a sine wave to go through. And that produces the CW, the new CW note, which is then filtered. And the output goes to the headphones. And it goes to an amplifier that reduces it to a proper value. And then it goes to this zita-njbridge back to the rig. And that's what's being transmitted. So it's in audio frequency CW mode, and the rig itself is set for Vox. So this is using the audio Vox that you would normally use on lower sideband, upper sideband AM. So we're using AFCW to get the Morse code through there. And as you're talking, you might see something show up there, right there, if you can see that. That is the ALC meter, so we don't really want that for CW. It's okay for voice. So we've lowered it just a little bit more so that it doesn't activate, and yet it still gives full output, because you don't want ALC distorting the rise time when you're using AFCW mode. So between the Morse code and the microphone. Now this microphone is important since we're splitting the channels. This condenser mic from this headset here needs some voltage, so you need to do a stereo to mono adapter, which is right here. And then to plug it into this RCA, I needed another adapter, so I have a 1/8 inch to RCA adapter. Then we have that split 1/8 inch stereo split to 2 channels here, 2 RCA females. One's for the Morse code, one's for the microphone here. And so that the mic is not transmitting all the time, we send it through a gate and a compressor. Otherwise it would be a lot of hiss like this. And you might not be able to hear that, so let me turn this down all the way. And we'll turn the gate off. So you don't want that being transmitted, and you don't want to hear it yourself because you're listening to your local side tone, not the other one. Here's what the voice would be sounding like if I did listen to the rig. So it's just enough to kind of throw things off. So that's how you adjust DUCA. And again, it squashes down the audio coming from zita-njbridge, only this is from the rig itself. This is the receive audio and the side tone monitoring, or the input monitoring audio. So it goes through a IAGC circuit here called V level, which keeps the volume fairly stable. And it raises it up if it's too low and takes it down if it's too high. So at a certain level, you can set this however you like. Goes into DUCA, comes out. But when this sidechain input is hit by either my voice coming out of this equalizer or the CW coming out of Zamgate's 2 filters, that takes everything down on the top channel here. So we don't hear anything from the rig itself until that setting is finished. So again, we have Morse code and voice being able to be transmitted from the laptop to the rig using Zeta. And the ad hoc mode, we have some different IP addresses, and that's the laptop right there. And let's see what this one is. This is the Pi's IP address when it's in ad hoc mode. And the same thing for the laptop commands for Zeta. That's what that's what I'm using to send audio, transmit audio from the microphone and the Morse code audio from Zamgate to the Pi which goes to the rig for transmission through the rig's, the K3S's own USB sound card. And this is the command to receive from the rig using Zeta audio over IP. And this is non-compressed audio. I think it's just PCM audio at 24-bit. And you can change that to 16 if you want, but I found the 24 has less distortion from the Morse code audio tones for AFCW, so I left it default at 24. Now on the Pi, we're using Jack Audio Connection Kit at these values here. Sample rate at 48,000, buffer size 128. And we're using QJack CTL. It's not that complicated. Here's the configuration we were using internally. And we have we're using Jack D-Bus. So that is what we're doing here. Now on the Pi, you had to blacklist the Pi's own analog sound card. There'll be a link in the video notes below on how to do that, or where to, what website where I found that worked for this. So when I hooked the USB cable right here from the Pi to the back of the K3S, the Pi sound card this K3S sound card registers in ALSA as the only sound card, so that when you bring up Jack, you choose that one. Which is this right here, this codec. So there are no other sound cards, and this second line is the same as the first, only it splits it with the 00 there, which is, you don't have to worry about that. That's all about Jack, and it'll be again a note about how to get Jack going on a Pi. This has been very effective, and it's been very stable. It's run for 3 days without any hiccups. An X-run, when an X-run hits, it's some kind of a buffer issue, and you always get an audio pop and snap. And at these particular settings on this Pi, and this is a Raspberry Pi 2B, it's done very well at these settings. I was quite surprised. And the Zeta has been operating very well, even at its default 10 milliseconds. I've had it down to 0 at ad hoc, and there was another video done about that in this YouTube video channel, which was kind of amazing. It only had 5 millisecond round trip delay. But for this one, I just wanted to run it in default mode and use DUCA. So you can do this over the internet or just over the local area network, which I'm doing right now. So let's go ahead and turn the power up, and let's see if we can send out a QRL question mark, and when you can watch the scope here. So we'll go back to the Pi and turn up some audio. Turn up the power a bit. And I'll go to the oscilloscope so we can watch it, and you can also watch this meter here. Is this frequency in use? So we turn power back down to 0. So that's basically the setup, and it's worked great. The unique thing about this particular coverage and demonstration is being able to use and showing how to use both the mic input and Morse code at the same time using AFCW for the mic and
KC4TT, KC4TT. You around, Teddy? This is Whiskey Bravo 4.
Turn that off for a second. And we have the mic coming in and being able to use both mic and Morse code with one mic jack. And look in the video notes if you're interested in some of this software. The equalizer I found is also helpful because you can tune up your voice. Here's what my voice sounds like without it. And it's not a great deal of difference, but when you turn it back on, it brings up the volume and you have a little extra bass, mid, and a little bit of treble. So you can adjust that according to your preference, and this is what you'll sound like when you're transmitted on the other end, whoever is receiving your signal. So for a Raspberry Pi, and even an old one, a Pi 2b, this is doing a great job at performing remote rig operations for both full duplex audio and remote rig control using FLRig. Thank you for watching.